Hi guys, in this video I'm going to run you through everything you need to know about logarithmic axes. Every section has been timestamped so you can easily jump to a section or rewatch it if you need to. Hope this helps. The equation for a straight line is y equals mx plus c. C is the y-axis intercept and m is the gradient. Plotting data that fits a straight line is very convenient, as we can easily measure and calculate the gradient of the line. Most relationships are not linear, however, and therefore don't naturally produce a straight line when graphed. For example, consider the cubic equation y equals 2x cubed plus 1. If we calculate the pairs of xy values that satisfy this relationship and graph them, it clearly does not produce a straight line. However, if we plot y against x cubed instead of x, on these axes the relationship does produce a straight line. If we substitute big Y for little y and big X for little x cubed, we can see with these axes our equation matches the form of a straight line. Furthermore, when comparing our new equation to y equals mx plus c, we can deduce that the gradient for our line is 2 and the y-intercept is 1. We are going to see how to plot a straight line for two different models in A-level maths. The first model is an exponential, and its parameters are very intuitive. Suppose we put £1,000 in a savings account that earns 5% interest a year. To calculate the balance at the end of the year, we can simply multiply by 1.05. To calculate the balance at the end of any future year, we can multiply by 1.05 as many times as we need. This equation is the same form as our exponential model. Comparing the two shows that a is the initial value. We can check this algebraically by setting x to 0 and calculating that y would be just a. We can also see from the comparison that b is the proportional change in y per unit change in x. Plotting y against x produces an increasing curve when b is greater than 1, and a decreasing curve when b is between 0 and 1. We can use logarithms to work out some axes that would produce a straight line for this relationship. First, we take logs of both sides. Next, we use the law for addition of logs to split up the right-hand side. Now let's use the rule for powers inside logs on the second log to bring down the power. To interpret what we have a bit more easily, let's reorder the terms now. If we plot log base 10 of y and x, this will produce a straight line. Furthermore, if we substitute big Y for log base 10 of little y, and big X for x, and compare the result to y equals mx plus c, we can see the gradient is log base 10 of b, and the vertical intercept is log base 10 of a. The second model we need to be able to plot a straight line for is y equals ax to the n. This model doesn't have a simple interpretation like the previous one, but if we set x equal to 1, we can see that y will always be a regardless of the value of n. In a modeling context, we could think of a as the value of what we are modeling after 1 unit of time, for example. If we plot y against x for this model, its graph changes depending on the value of n. To plot this relationship on axes that will produce a straight line, we follow the same procedure we used for the first model. First, take logs of both sides, split up the log on the right-hand side, and bring down the power on the second log on the right side. To make this easier to interpret, let's reorder the terms again as well. If we plot log base 10 of y against log base 10 of x, this will produce a straight line. Furthermore, if we substitute big Y for log base 10 of little y, and big X for log base 10 of little x, and then compare the result to y equals mx plus c, we see the gradient is n, and the vertical intercept is log base 10 of a. That's the end of the video, guys. I hope you found it helpful. If you did, please drop it a like, that helps me out a lot, and consider subscribing to the channel to find out when I release new videos. Thanks, and I'll see you in the next one.